Hello students. Now the continuation of the electrophilic addition reactions with some exceptional cases also. So in the previous cases we discussed normal conditions and ring expansions and less stable to more stable carbocation rearrangement reactions. In this now one example, if CH2 double bond CH2, when ethylene molecule is reaction with the HF molecule, generally. So what we expected the product is here CH2 H CH2 F. This is the product. But generally this kind of product formation is not possible. So why? Because HF molecule is a weak acid. This one is weak acid. So weak acid means it is unable to release the H plus ions. So electrophile formation is not possible in this. Electrophile H plus not possible. This is the one kind of exceptional case. And one more. If any kind of one reaction given like this, it is a propane molecule reaction with the HI. So reaction with HI means, so this one also generally we expected the product is in this. The expected product I here H1. But what happens here in this given condition, it is also not possible. Generally HI molecule, it dissociate to form H plus plus I minus, H plus plus I minus. So in this first step only, I minus alone it acts as a strong reducing agent. Okay, strong reducing agent. So the strong reducing agent again reaction with the H plus. Again it is reaction with the H plus only. It convert into a HI formation. That means it is a reversible process. This one is a reversible process. So in this case also the electrophile formation is not possible. So that's why. So these two not involving in the reactions. This is the another condition. Next, third case. If a benzene is reaction with the HCl molecule. So what happens here? Here also no reaction. No reaction. So why benzene? Generally we know that benzene is a nucleophile. So why nucleophile not involving with HCl directly means if H plus and Cl attacks on this, the aromatic nature is aromatic compound converted into non-aromatic non-aromatic compound. Aromatic is only always stable, but a non-aromatic is unstable. Okay, so this kind of stable to unstable formation is not possible. That's why in this given benzene reaction with HCl, electrophile formation is not possible. Okay, electrophile is not possible. So that's why here there is no reaction. This one also very, very important. The next another reaction. CF2 double bond CF2. So this molecule tetrafluoroethane. The name of this one is called tetrafluoroethane. The tetrafluoroethane is reaction with the HBr case. HBr. So generally this kind of reactions also not involving in the electrophilic addition reactions, not possible. Electrophilic addition reaction is not possible. So what is the reason here? Why this one is not involving in the reaction? Reason. Then generally fluorine it acts as a minus I group only. So minus I group means what about the electron density? Very less. Okay. The pi bonded electron density here, this one, this pi bonded electron density. Okay. Due to the minus I group, this one decreases the pi bond electron density. If a pi bond electron density decreases, then how it is donate the electrons to H plus? So it is not possible. So that's why this kind of reactions also not involving in the reactions. So these are the few exceptional cases. Okay, these are the few exceptional cases. The next, another kind of reactions. So these are also involving in the electrophilic addition reactions only. Before we discussed the HCl, HBr molecules only. But now, if other than that molecules like Cl2, Br2 molecules, chlorine and bromine molecules, but in the presence of solvents also important. So this chlorine bromine mostly involves in presence of CCl4, CHCl3, CH2Cl2. Okay, so these are also other kind of reagents. Next, aqueous sodium hydroxide or aqueous potassium hydroxide. So presence of these conditions are another one also, sodium cyanide. Okay, so these all are the chlorine bromine reaction with the alkenes or alkynes in the presence of CCl4, CHCl3, CH2Cl2 or aqueous medium of KOH or NaOH and NaCN. Okay, these are the three types of reagents. So presence of these conditions, how the chlorine bromine involving in the reactions. So this kind of reactions we will discuss now. Next, first one, CH2 double bond CH2. So ethene molecule, when it is reaction with the chlorine in presence of first one CCl4 molecule, CCl4 molecule. Another one is aqueous sodium hydroxide condition. Then what happens in these two cases? What are the products? Now, in the first case, the product formation is this one, 1, 2 dichloro ethane is the product. If aqueous NaOH is involving in the reaction, what happens? CH2, CH2, Cl, Cl plus CH2, CH2, Cl, OH. Two products only it gives. This is also very, very important. This one gives here two different products, but the CCl4 condition gave here only one kind of product. Then what is the difference? How they gave like these products only we will discuss now in the mechanism. First case, presence of CCl4, then Cl2 molecule, this Cl2, in the presence of CCl4, it dissociate to form Cl plus Cl minus molecule. One is the electrophile, another one is the nucleophile formation. But before case, the CH2 double bond CH2, this is a nucleophile condition only. It must involving in the reaction means it acts as a nucleophile. Then which one involves with that? Cl plus electrophile. If it is donate electrons to Cl plus, this group convert into CH2 single bond CH2 Cl. This carbon get the charge positive. So further, which one involving in the reaction with the another Cl minus. If Cl minus attacks on this carbon, now product formation is CH2, Cl, CH2, Cl. This is the first product only. This is the mechanism with the CCl4. So why Cl2 here gave like this means the CCl4 molecule is non-polar. Cl2 also non-polar. So like dissolves like. If like dissolves like means Cl2 dissociate to form Cl plus and Cl minus condition. So this is the first case. Next coming to the second one. This one is the first case. Next, in the second case, when water molecule aqueous form of sodium hydroxide means this one. NaOH with a H2O molecule. Aqueous form of sodium hydroxide. If it is reaction with which one? Chlorine. This is also important. The aqueous form of this one convert into first NaCl, sodium chloride plus HOCl. So this is the product formation. Okay, HOCl plus NaCl. In the presence of which one it is? Water molecule. Aqueous NaOH means presence of water. Sodium hydroxide reaction with chlorine. It forms sodium chloride plus HOCl. Sodium chloride is a salt formation, but HOCl is compared to NaCl, it is highly reactive. Reactive. So the reactive nature of this molecule easily involving in the double bonded carbon atoms. So CH2 double bond CH2 with reaction with HOCl. So HOCl, what is the meaning here? Chlorine forms positive, OH is the minus. So which one is electrophile in this? Chlorine is the electrophile. Now this carbon donate the electrons to chlorine. Then this group convert into CH2. This one CH2, here CH2, single bond, CH2, Cl. This carbon has positive charge. Further, which one involving in the reaction? OH minus. This OH minus attacks on the carbocation. The final product is CH2, single bond, CH2. Here already it has Cl, 1 OH. Now, the final product in this is the product. In the second case, this is the majorly forms. What about this one means? If chlorine in the presence of aqueous NaOH, again it slightly dissociate to form Cl plus and Cl minus. So again same condition. Okay, again the above case like CCl4 in the Cl2 like in the aqueous NaOH, chlorine also dissociate to form less amount of. After that, the Cl2 molecule in presence of aqueous sodium hydroxide, it forms Cl plus and Cl minus. This is the less amount only forms. Less amount. The less amount of this molecule. Now, further it is reaction with CH2 double bond CH2. Which one start the reaction now? Electrophile. Now this carbon donates to this. This one convert into CH2, CH2, Cl. Here positive charge. Next, one more chlorine Cl minus. It is attacks on this carbon. Now finally it forms CH2 bond CH2 Cl Cl. This is the minor product. This one is the major. This one major. This one is minor product. So that is the identification. It is minor. Okay. So these are the reactions with the presence of CCl4 or presence of aqueous NaOH. The next one more reaction we will discuss now. One more reaction. Suppose here the reactant is CH3 CH double bond CH2 given. When it is reaction with the bromine molecule Br2, bromine molecule presence of sodium cyanide. This is the given reaction. When bromine is reaction with the sodium cyanide condition. So what are the products here? That is also important. The product formation in this one is CH3 CH Br CH2 Br plus CH3 CH CN CH2 Br. Okay, so these are the conditions. In these two, how it will form first? If a Br2 in the presence of sodium cyanide, it is dissociated to form Br plus and Br minus. These are the products. Okay, Br plus and Br minus case. If only Br involving in the reaction means Br plus Br minus gives this is the product. If NaCN reaction with the Br2 molecule, NaCN with Br2, it dissociates to form sodium bromide plus bromocyanide. Bromocyanide. Cyanide means that one get the charge negative, bromine get the charge positive. When this molecule reaction with the propane molecule CH3, CH double bond CH2. Now first which one start the reaction? Br plus. So this one attacks on the bromine. It converts into CH3, CH here plus CH2 Br. The next further step Cn minus. If Cn minus attacks on this carbocation, CH3, CH, Cn, CH2, Br. These are the products. So why we are writing always here Br opposite side, Br Cn opposite side? Why? Because here bromine, each bromine has how many lone pair of electrons? 3 lone pair of electrons. 3. So size also large. Repulsions in between them is very high. Here nitrogen has 1 lone pair of electron. Here bromine has 3 lone pair of electrons. Due to the repulsions. So due to that repulsions only, so these molecules anti to each other. That is the meaning. That's why these are formed transformation only. Okay. So this kind of transformation when bromine and chlorine molecules converted into like this. Okay. Sometimes these are all forms bromonium ions, chloronium ions also in the given reactions also. So that is how it is forms. One small example I will explain that. CH2 double bond CH2. If it is directly reaction with this kind of molecule. Now observe this carefully. The nucleophilic nature of this one. Chlorine, generally the chlorine molecule is, we discussed already, that is act as a electrophile, neutral electrophile. So if it is donate electrons to one chlorine, okay, one chlorine atom, then what happens here? One bond will breaks. If one bond will breaks means automatically this one again donate the electrons to this carbon atom. Now this group converts into CH2 single bond CH2 Cl plus CH2. It is a one chloronium ion, cyclic chloronium, cyclic chloronium ion. It is only developed. Next, in the further step, which one remaining in this Cl minus only? Here Cl minus only in the present. That Cl minus, if it is attacks on this carbon, here density increases more. This bond will breaks towards chlorine atom. That time only this compound forms CH2, CH2, both opposite side. Here one chlorine attached, here also one chlorine. This is the another kind of procedure. Both same only, maximum both same, but this kind of cyclic chloronium ion also formed. This one is the intermediate. Okay, cyclic chloronium ion intermediate develops in the given reaction. This is another kind of reaction. Suppose sometimes methyl alcohol also involving in the reaction with alkenes. That kind of reactions also important. So sometimes means what happens here? Generally, I will explain one reaction. CH3C bond CH3 double bond CH2. This is the reactant molecule. When the reactant molecule is reaction with chlorine, presence of which one? Methyl alcohol CH3OH. Methyl alcohol condition. Then methyl alcohol reaction with this chlorine means what happens here? This OCH3 alone also it is involving in the reaction, and HCl is the stable molecule. It converted into HCl form. Okay. The finally one product already two chlorines only involves. If it is act as a nucleophile above case only. In the above case, this chlorine only directly reaction with this, it gives two chlorine atoms on the both sides in opposite directions. Okay, antiposition. If a methyl alcohol also involving in the reaction, so what happens here majorly? Methyl alcohol with chlorine. These two combine to form CH3OCl. This is the reaction between the chlorine and CH3OH. Now this one OCH3 minus Cl plus. Okay, that means what? Always this negative charge attacks on the this carbon. This chlorine plus attacks on the this carbon. Attaches to that. Now we will get here final product is. Now I'm writing here the final product CH3 C bond CH3. Same only na this one. Here add OCH3 group. OCH3. Next CH2 Cl. This is the final product. Okay. One more. Two chlorine atoms also attached. This one also another product. So if methyl alcohol involving in the reaction, this one is the product. Okay. So now we will discuss another kind of reactions also. Okay. Another one. Next, one example in this. Generally, sometimes they will give this is the double bonded carbon atom means cyclohexene. It is a bromine molecule. Okay, this one is bromine molecule. So in this bromine molecule, they will give CCl4 or CHCl3 or whatever it is the compound given. We can write this product like this. Now, this product we can write like this. That means what? It is a trans product. Two bromine atoms attached on the opposite side. It is a trans product. Okay. Next, one more example. It is a cyclic ring only, 5-member ring with one double bond, cyclopentene. When cyclopentene is reaction with NBS. NBS, presence of hydrolysis. Presence of hydrolysis. So what is the product developed in this case? That product developing is in this. Now, in these two cases, OH, Br. Again, this one here, each bromine has a 3 lone pair of electrons. That's why trans. Here also bromine has 3 lone pair electrons. Oxygen has 2 lone pair of electrons. Now, what happens here? Why this one NBS means what first? NBS. N bromo succinamide. Okay, the name of this compound is N-bromo succinamide. In this N-bromo succinamide, first what happens? We will discuss in this. The N-bromo succinamide structure is this one is the N-bromo succinamide. In this succinamide, first H plus only involving in the reaction. H plus. Now this oxygen is more reactive to donate electrons to H plus ion. This group converts into like this here double bond O, here O. After donation of this, these electrons moving towards to this oxygen. Now single bond OH. Okay, single bond OH means this carbon get the positive charge. Here this carbon get the positive charge. What happens next? The adjacent group has here sigma electrons. It donate electrons to this carbocation. If it is donate the electrons to carbocation means bromine eliminates without bonded electrons. Without bonded electrons. Now finally, this group converts like this. And here OH, here double bond. Okay, here double bond. Okay. Finally, now this oxygen donate the electrons to here. These electrons comes to here. This nitrogen absorb the proton. Why? Because it is looks like a enol type form. Enol. So it is called iminol. Iminol. Iminol involving in the tautomerism. This process is called tautomerism. In this tautomerism, this group again converts into now OH group dissociate to form double bond and H. It is called succinamide. So which one are developed here? Br plus. So this Br plus is a electrophile. Electrophile. In this case, first which one start the reaction? Br plus. This Br plus attached to this carbon, this one donate the electrons. Br plus only it donate electrons. Then finally it converts into Br, here positive charge. Next, water molecule. It acts as a nucleophile, right? It donates the electron pair to carbocation. Here Br, here O, H, H, one positive. Now one hydrogen donate the electrons. Why? Because here first which one started? H plus only started here. So finally H plus elimination takes place as a catalyst. Now final product is here bromine, here OH. Why? Because already if a bromine on the present side means OH attacks on the back side. So this is the major product. Okay, students. Next, another stereochemistry of electrophilic addition reactions we will discuss in another video. Thank you.